Okay, so the second most employed method for the generation of terahertz radiation is optical rectification. In the optical rectification, what we require a non-linear optical medium. What I mean by non-linear optical medium, it is the medium which is having second order non-linear susceptibility. Again, uh, coming to the basics of susceptibility. Susceptibility is somehow related to the permittivity, which tells us how much electric field can enter inside a medium. So say we have applied an electric field and we have kept a medium. uh, in the vacuum there is a value of electric field. Now, what is the value of that electric field inside the medium? That will be decided by the permittivity of that medium. So, if the response of the medium towards the electric field is nonlinear, that means it is varying by the power of greater than 1. In that case, it is a nonlinear medium. Now, if it is having a second order nonlinearity, that means the susceptibility is having the power 2, then we'll be having a nonlinear optical medium with second order of susceptibility. What happens is that in such kind of medium, when an intense electromagnetic fields uh, or electromagnetic laser beam is made to fall, there are many processes which takes place, which includes some difference frequency. Then one process is the second harmonic generation, and also there is this optical rectification which takes place. What happens is the incoming laser beam changes the polarization of the medium. That means its charge separation takes place because of the electromagnetic field, and because of that charge separation, which is not frequency dependent, uh, that part which is not frequency dependent, when we solve the expression of that polarization vector, there is a term which is not having omega in it. Omega, by omega I mean frequency, which is not having omega in it, and that leads to the generation of terahertz radiation, and the process is called optical rectification.